Chapter 1.4.3 Autoscaling Workloads. Kubernetes allows for scaling workloads based on resource demand, improving elasticity and efficiency in the cluster. Scaling can involve increasing or decreasing replica numbers or adjusting resources for replicas. Horizontal scaling means adjusting replica numbers, while vertical scaling involves adjusting resources. There are both manual and automatic scaling options available in Kubernetes, depending on the specific use case. Overall, Kubernetes provides flexibility in managing workloads to ensure optimal resource allocation based on demand, enabling clusters to adapt quickly and efficiently to changing requirements. Scaling workloads manually. Kubernetes allows for manual scaling of workloads by using the kubectl CLI. Horizontal scaling involves running multiple instances of an application, while vertical scaling requires patching the resource definition to adjust CPU and memory resources assigned to containers. Examples of both strategies are provided below. Scaling workloads automatically. Kubernetes supports automatic scaling of workloads, which can be achieved through various methods. Horizontal scaling can be implemented using a horizontal pod autoscaler, HPA, that adjusts the number of replicas in a workload based on resource utilization, such as CPU or memory usage. Vertical scaling can be achieved using a vertical pod autoscaler, VPA, which is a separate project on GitHub that allows for custom resource definitions to scale resources of managed replicas. In-place resizing without restarting pods or containers is possible with the in-place vertical scaling feature gate in Kubernetes v1.27 or later. Autoscaling based on the cluster size can be done using the cluster proportional autoscaler, which watches the number of schedulable nodes and cores to scale replicas accordingly. The cluster proportional vertical autoscaler adjusts resource requests based on cluster size. Event-driven autoscaling can be implemented with Kubernetes Event-Driven Autoscaler, KEDA, to scale workloads based on events like the number of messages in a queue. Autoscaling based on schedules can be achieved using KEDA in conjunction with the cron scaler to define schedules for scaling workloads in or out, reducing resource consumption during off-peak hours. These various methods offer flexibility in scaling workloads in Kubernetes based on different criteria. Scaling cluster infrastructure. The text discusses how to scale cluster infrastructure by adding or removing nodes if scaling workloads is not sufficient. It suggests reading more on cluster autoscaling for further information on this topic.